Our objective in this lesson is to solve quadratic equations by completing the square. Let's have a quick review. Solve the following quadratic equations. By this time, you already know how to solve quadratic equations by extracting the square roots and factoring. We are going to analyze these two quadratic equations and determine the appropriate method of solving them. The first one, we do not have a linear term, and 121 is a perfect square. So what we are going to use is extracting the square roots. First, I'm going to move negative 121 on this side and then extract square roots of both sides. So this radical symbol and exponent 2 will cancel out. Since our c is greater than 0, then we are expecting two roots, positive and negative. And square root of 121 is 11. So we have x is equal to positive and negative 11. Number 2, we have complete quadratic equation and we are going to use factoring. First, I'm going to move 18 on this side and equate this to 0. I'm going to determine the factors of 18. Those are 1 and 18, 2 and 9, 3 and 6. I'm going to bring out my magic x. On top, I'm going to write the constant term, negative 18. At the bottom is the numerical coefficient of the linear term, which is negative 3. Then I am going to choose which among these three sets of factors will give me a sum of negative 3. That would be 3 and 6. To have a sum of negative 3, the bigger number among these factors should be negative. Quick checking. 3 times negative 6 is negative 18. 3 plus negative 6 is negative 3. So here are the factors that we are looking for. X plus 3 and x minus 6 equals 0. Let us apply the zero product property rule. X plus 3 is equal to 0 or x minus 6 is equal to 0. Moving this on the right side will give me x equals negative 3. And this one moving on the right side will give me x equals positive 6. Kindly check by substituting the answers that we got in the original equations. Today, I am going to teach you another method of solving quadratic equation, and that is by completing the square. Here, the quadratic equation in the form ax squared plus bx plus c equals 0 is transformed into quantity x minus h squared is equal to k, where k is greater than or equal to 0. Would you know why k must be greater than or equal to 0? Because if you extract both sides, k could not be negative. It will give us imaginary roots. Here are the steps in solving quadratic equation by completing the square. I will discuss each one of these as I go along with an example. Let's have the first one. X squared minus 2x minus 15 is equal to 0. First step is to isolate all variable terms on the left side of the equation and the constant term on the right side. So all terms with a variable will be on the left side and the constant term should be on the right side. So I'm just going to move this one on the right. It will become positive 15. Step 2, if the coefficient of x squared is not 1, divide both sides of the equation by the coefficient. But since in this example, the numerical coefficient of x squared is 1, then I'm just going to simply copy it. Step 3, complete the square. So here is the exciting part. How do we complete? You add the square of 1/2 of the coefficient of x on both sides. The left side of the equation becomes a perfect square trinomial. So let us prepare first where are we going to put the term that we are going to add. So here we are going to put the term that we are going to add. And how do we determine the term? First, you get the numerical coefficient of the middle term. It doesn't matter if you include the negative sign or not. And then you divide it by 2 because it says here 1/2 of the coefficient of x. So let us divide this by 2, and 2 divided by 2 is equal to 1. And then you square the answer. 1 squared is equal to 1. So we are going to add 1 on both sides of the equation. It says here the left side of the equation becomes a perfect square trinomial. So this portion. So our next step is express the perfect square trinomial as a square of a binomial. And how do we do that? You take the square root of the first term. The square root of x squared is x. You take the square root of 1. The square root of 1 is 1. Copy the sign of the middle term, that would be negative, and then quantity is squared. So that is how you express a perfect square trinomial to a square of a binomial. Equals 15 plus 1 is equal to 16. Next step, solve the resulting equation by extracting the square root. Let us extract the square roots of both sides. So the radical symbol and this exponent will simply cancel out, leaving as x minus 1. And since our c here is greater than 0, then we have two possible roots, positive and negative. And the square root of 16 is 4. So we have x minus 1 is equal to positive and negative 4. Let us solve for x. Let us move negative 1 on the other side. It will become positive 1. Let's have the first one. 1 plus 4. And 1 plus 4 is equal to 5. Another value is 1 minus 4. And that is equal to negative 3. Last step is to check the solutions. And how do we do it? We simply substitute the values that we get to the original equation. So let us substitute 5 first in all of our x's here. Are they equal? 5 squared is 25 and 2 times 5 is 10. Is it equal to 0? 25 minus 10 is 15, and 15 minus 15 is equal to 0. So yes, they are equal. Next, let us substitute negative 3 in all of our x's here. Are they equal? Negative 3 squared is positive 9. Negative 2 times negative 3 is positive 6. Minus 15, is that equal to 0? 9 plus 6 is 15, and 15 minus 15 is equal to 0. So yes, they are equal. Therefore, our answers, x is equal to 5 and x equals negative 3 are correct. Try this. 2x squared plus 2x minus 4 is equal to 0. Again, step 1 is to isolate all variable terms on the left side of the equation and the constant term on the right side. So the constant term here is negative 4. We're going to move this on the right side. Next step, if the coefficient of x squared is not 1, divide both sides of the equation by the coefficient. Just like in this example, the coefficient of x squared is not 1, it is 2. So we are going to divide both sides of the equation by this numerical coefficient. So 2 and 2 will simply cancel out, as well as the 2 and 2 here. And then 4 divided by 2 is 2. So we have x squared plus x is equal to 2. Next step, let us complete the square. Let us prepare where are we going to put the additional terms. Let us determine the numerical coefficient of x, and that is the invisible one. Divided into half, so divided by 2, and 1/2 is still 1/2. Square this, and this will give us 1 squared is 1. 2 squared is 4, 1/4. So we are going to add 1/4 on both sides of the equations. And then the left side of the equation becomes a perfect square trinomial. So let us express this perfect square trinomial into a square of a binomial. Determine the square root of x squared, and that is x. The square root of 1/4, it is already here, that is 1/2. Copy the sign of the middle term, so plus, and then quantity is squared, equals 2 plus 1/4. Next step is to solve the resulting equation by extracting the square root. But before that, let us simplify this. Let us copy the left side. To simplify this, we are going to need the LCD. The denominator of 2 here is the invisible 1. The LCD of 1 and 4 is, of course, 4. 4 divided by the invisible 1 here is 4 times 2 will give us 8. 4 divided by 4 is 1 times 1 is still 1. So plus 1. 8 plus 1 is equal to 9. Now we can extract the square roots of both sides. So this radical symbol and the exponent will simply cancel out, leaving us x plus 1/2. The square root of 9 is 3. The square root of 4 is 2. Since our c is greater than 0, then we are expecting two roots, positive and negative, 3 over 2. Let us move 1/2 to the other side. It will become negative. Let's have the first value of x, negative 1/2 plus 3/2. Since the denominators are the same, we simply work on the numerator. Negative 1 plus 3 is 2. And then copy the denominator, so it is 2 over 2, and that is equal to 1. The second value of x is negative 1/2 minus 3/2. Again, the denominators are the same. Let's work on the numerator. Negative 1 minus 3 is negative 4. Copy the denominator over 2. Negative 4 divided by 2 is equal to negative 2. And finally, let us check the solutions. So let's do a quick check in here. Let us substitute 1 here. If this is 1, 1 is squared is 1, and 1 times 2 is 2. So we have 2 here. If this is 1, 2 times 1 is 2. So we have another 2 here. So 2 plus 2 is 4, and 4 minus 4 is equal to 0. The second value, if this is negative 2 is squared is positive 4. And 2 times positive 4, the first term will become positive 8. If this is negative 2, 2 times negative 2 is negative 4. So the second term is negative 4. So we have here 8 minus 4 is 4, minus 4 is equal to 0. So yes, our answers x equals 1 and x equals negative 2 are correct. Let us do extra challenge. Your father gave you 600 meters of fencing material to enclose and divide his rectangular farm into flowering plants and fruit-bearing trees equally. Determine the length and width of the farm with the maximum area possible. First, let us construct a rectangular farm. Let us label this as our length and this one as our width. Your father gave you 600 meters to enclose. So we're going to enclose this rectangular farm and divide it equally into flowering plants and fruit-bearing trees. So we are going to divide this equally. So meaning the material that you are going to use to enclose this rectangular farm and divide it into two is equal to 600 meters. If this is length, then this is also length. So we have two lengths. If this is width, this is also width, and this is also width. So we have three widths. And that is equal to 600. Let this be our equation 1. Another equation that we know is the area of a rectangle, and that is equal to length times width. Let this be our equation 2. From equation 1, I have here two variables. And what I am going to do is to eliminate one variable here. Meaning, I am going to express one variable in terms of the other. So let us say I would like to eliminate L, the length. So I'm going to subtract 2L on both sides of the equation. This will be 2L minus 2L will simply cancel out. 3W minus 0 is still 3W. And then I have here 600 minus 2L. To solve for W, I'm going to divide both sides by 3. So 3 and 3 here will simply cancel out. So I have W. 600 divided by 3 will give me 200. And negative 2L divided by 3 is simply negative 2/3 of L. Let this be my equation 3. From equation 2, area is equal to length times W. I am going to substitute the value of W here in this equation. So it will become area is equal to length times W. This is the value of my W from equation 3. I am going to distribute this L. So L times 200 is 200L. And then L times negative 2/3 of L will become negative 2/3 of L squared. Again, L times 200 is 200L. L times negative 2/3 of L is negative 2/3 of L squared. Let us continue. This time, I'm going to rearrange this in such a way that the quadratic term is written first. So this will become A is equal to negative 2/3 of L squared plus 200L. I just rearrange this so that the quadratic term is written first and then followed by the linear term. And then I am going to factor out negative 2/3. So I'm going to factor out negative 2/3. When I factored out negative 2/3 from negative 2/3 of L squared, what was left is simply L squared. Now I'm going to factor out negative 2/3 from 200L. So how are we going to do it? Simply divide 200 by 2/3. And that is the same as 200 times 3, the denominator, and that is 600, divided by 2. 600 divided by 2 is 300. So I have 300L. Why is it negative? Because we factor out the negative here. Let us do quick checking. Negative 2/3 times L squared is negative 2/3 L squared. Negative times negative is positive. 2 times 300L is 600L. 600L divided by 3 is 200L. So this is correct. Now, notice that the numerical coefficient of my quadratic term is just 1. And I have here a linear term. So I can do now completing the square. So let us determine the numerical coefficient of our middle term, and that is 300. Again, it doesn't matter if you include the negative sign or not, because after all, we are going to square the answer later. Divide this by 2 into half, and 300 divided by 2 is 150. And then we are going to square this, and this is equal to 22,500. So this is what I'm talking about. Even if you include the negative sign here, when you square it, it will still become positive. So we are going to add 22,500 here. If we added 22,500, we should also subtract 22,500 as if we did nothing in our equation. Because if you will simply add 22,500 and then you altered the original equation. So what you add, you also subtract. Now, since I want to produce perfect square trinomial, I have to remove this from the parentheses. To do that, I am going to multiply first negative 22,500 to the factor outside, which is negative 2/3. So let us do that. Negative times negative will become positive. 2 times 22,500 is 45,000. And 45,000 divided by 3 is 15,000. So it will become negative 2/3, and then my perfect square trinomial, and then the answer that we derive, 15,000, outside my PST, my perfect square trinomial. Let me just make this clear once more. So I have here negative 2/3. And then this portion is my PST, my perfect square trinomial. And again, the 15,000 comes from negative times negative is positive. 2 times 22,500 is 45,000. Divided by 3 is 15,000. I have here my PST and I'm going to express it as a square of a binomial. The square root of L squared is L. The square root of 22,500 is already here, 150. Copy the sign of the middle term, negative, and then quantity is squared. So negative 2/3, I simply copied it. Then this is the square of the binomial of my PST. Again, square root of L squared is L. Square root of 22,500 is 150. Copy the sign of the middle term. And then quantity is squared. Then plus 15,000. From this equation, I already have L minus 150. And applying zero product property rule, I'm going to equate that to 0. Negative 150 on the other side will become positive 150. I already have the value of length. Now, from equation 3, I can solve for the value of W since I already have the value of length. I am going to substitute 150 in this equation. 2 times 150 is 300 and 300 divided by 3 is 100. 200 minus 100 is equal to 100. Therefore, the answers to the question length and width of the farm. Length is equal to 150 meters and the width is equal to 100 meters. Let us do a quick check-in here. From equation 1, 2L plus 3W is equal to 600. Let us substitute our values, 150 for L and 100 for W. Are they equal? 2 times 150 is 300 and 3 times 100 is also 300. Are they equal? 300 plus 300 is equal to 600. And yes, they are equal. Therefore, our answers are correct. For the summary, here are the things that we discussed in this lesson. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. Solve by completing the square. So first step, we are going to isolate the constant term on the right side. It will become negative 12. Let us determine the additional term, but first let us prepare where are we going to put it. The middle term is 7. Let us divide it into 2. It is still 7 over 2. Let us square this. 7 squared is 49. 2 squared is 4. So we have 49 over 4. We are going to add 49 over 4 on both sides of the equation. Now let us express this left side, the perfect square trinomial, into square of a binomial. The square root of x squared is x. The square root of 49 over 4 is already here, 7 over 2. Copy the sign of the middle term, that is minus, and then quantity is squared. For the right side, we have to determine first the LCD. The denominator of 12 here is the invisible 1. The LCD of 1 and 4 is 4. 4 divided by 1 is still 4 times negative 12 is negative 48. 4 divided by 4 is 1 times 49 is still 49. Negative 48 plus 49 is equal to 1. So we have 1/4 on the right side. Now we can extract the square roots of both sides. So this radical symbol and the exponent will simply cancel out. The square root of 1 is 1. The square root of 4 is 2. Since our c is greater than 0, then we have positive and negative is square root of 1/4, and that is 1/2. Let us move negative 7 over 2 on this side. It will become positive. The first value would be 7 over 2 plus 1/2. The denominators are the same. Let us work on the numerator. 7 plus 1 is equal to 8. Copy the denominator divided by 2. And 8 divided by 2 is equal to 4. The second value is 7 over 2 minus 1 over 2. Again, the denominators are the same. Let us work on the numerator. 7 minus 1 is 6 divided by 2. 6 divided by 2 is equal to 3. I want you to check our answers by substituting these values in the original equation. And then comment down below if you got them equal. Gets? Our next lesson is solving quadratic equations by quadratic formula.